Hello and welcome to SudoKanard. We're here to solve this X-sum Sudoku creator, which is also called N-sum Sudoku, I think, by Richard Stolk for the Dutch Sudoku Championship. And the special rule is that this number, well, any number outside the grid, is the sum of the first few digits, and the number of digits we must add is the greater of the first two digits. For example, this 10 could be the sum of three digits. Let's say we have a 1 and a 3 here and a 6 there. And the greater of the two digits here is 3. We take the sum of the first three digits, and that works. Except the 6 won't work with the 3, but that's the idea. So where do we start? This 3 will be the sum of at most two digits. And two digits, we take the sum of two digits only if it's 1 and 2. Because if you put another digit than 1 and 2, then we must sum more than two digits. So that's a 1-2 pair. And I think I will use some coloring to see that this clue has been used. This 6 can't be the sum of two digits, because then it would have to be 2 and 4, and the special rule will mean we take the sum of 4 digits, not 2. So that doesn't work. So, well, we will never take the sum of exactly two digits, because that's the only case it happens. So, but 4 digits will make a sum of 10 at least. So this is the sum of 3 digits, and the sum of 3 digits giving 6, that's the 1, 2, 3. So 3 is not here, that's the sum of 3 digits, and this is good. Oops. So this down now, could it be the sum of 3 digits? If I try to put a 3 here and say it's the sum of 3 digits, then it means that the other digit must be less than 3, and you see that this breaks for multiple reasons. One of them being that the sum is 6, not 10. So we won't take the sum of 3 digits, but 4 digits, which means that the digits are 1, 2, 3, 4. So those are 3 and 4. That's not a 3, that's a 3. And the sum is 10 indeed. Now this digit is bigger than that, because 1, 2, 3, and 4 are here. 6 won't work, because the sum of 6 digits is at least 21, so that can only be a 5. We take the sum of the first 5 digits, so those 4 digits sum to 12 without using the 5. That is 1, 2, 3, and 6. So that's a 3, that's a 6, and that's a 1, 2 pair. We also have a 7, 8, 9 triple in here. And 37. So let's remember that the sum of all digits on a row is 45. So 37 is missing the last digits summing to 8. So we're missing the last two digits. So the bigger digit in here is a 7. And the only digit lower than 7 is 4 on this row. And that's an 8-9 pair. So this 37 is fulfilled. And that's interesting regarding this 18. We will take at least 4 digits, but we won't take 7 digits. The sum would be much bigger than 18. So that can't be a 7. But we could still take the sum of 5 digits. 3 digits won't work. Well, that's at least 4 digits. 6 won't work. If I try to put a 3, then those 2 digits could have a sum of 11. So I don't think that can be resolved right now. So 9 will be the sum of at least 3 digits, because 2 digits gives a 3. And 4 digits would be too much, so we have a 3 in here. And the other digit is a 1 or a 2. which means so we have a 3 somewhere with a 1 or a 2. With 3 and 2, that's a 4. With 3 and 1, that's a 5. I won't pencil mark that right now because there's still some work to do. 43. Only 2 is left out, so 2 is here. This ambiguates all this lot. And we have 8 digits in here. So there's an 8, but there's no 9 in here. Oh, and this 8, by the same logic as here, this 8 must have the sum of 3 digits, not 2 and not more than 3. So there's a 3 in here with a 1 or a 2. And the third digit is never an 8, so 8 is here. And actually this 43 is fulfilled. But now with 3 and 2, the third digit would have to be a 3. So that's a 3 and 1. And the third digit is a 4, and that's a 2, and that's the 3, and this is 4. To complete to 9. And this 8 is fulfilled as well. All right. This 10 now. 10 is the sum of at least 3 digits, and at most 4, but 4 is not available. So it will be 3 digits. This must be smaller than 3, so that's a 2. And to complete to a sum of 10, that must be a 5. 6, 7, 6, 7, 9, triple here. So that's 10, and it means that the sum of the remaining digits must be 35, so that's the sum of 6 digits. And the other digit must be smaller than 6 without being without being a 1, so the other digit must be a 4, like this. And here we have 1, 7, 8, 9. Is it worth pencil marking? Perhaps not. But now this 37 is fulfilled. 31 is the sum of, well, at least, not 6 digits, so at least 7 digits. 8 would be too much. The missing digit would have to be 14. So that can only be 7 digits, meaning that those two sum to 14, so that's a 9. Here we need 6 and 8. 31 is done. So what about this 18? We now know more about this column. It won't. If I try to put a 5 here, that's 9, and we need 18. So those 3 digits should sum to 9. But the available digits here are 1, 6, 7, 9, and you can't find 3 digits among them summing to 9. So 5 doesn't work here. It can only be 1. And we need 2 digits summing to 13. Without using 4, without using 8, they can only be 6 and 7. So that's the 6, that's the 7. We get the 9 at the bottom. And this here is a 5. 1 is here, 6, 8, and 9. Well, so mark those. Up there we still need 2 and 3. And those are from 5, 8, and 9. All right. What about this 14? 14, it can't be more than 4 digits because 5 digits sum to at least 15. 4 is not available, so that must be a 3. Those two sum to 11, so they must be a 2 and a 9. That's 8. This 14 is done. There's a number of possibilities here, but the only clue I haven't used yet is 15. Oh, first I do some Sudoku, I think. 8 is not here, it's not here, so that's 8. This can only be 5 or 9. And those are from 7, 5, and 9. There must be a 4 in here, it's here, so that's also from 5, 7, 9, can only be 5 or 9. This can only be 1 or 9. Not sure that's so useful, except, yes, let's see the options, that's not A. So if we put a big digit here, then it will mean, no, another way of seeing this. 15 is the sum of a certain amount of digits, and the amount of digits is the greater of those two. And we know that 15 is the sum of at most 5 digits. So no number here can be bigger than 5. So this has to be a 1. And that's, oops, and that's the 9, and that's a 7, 8 pair. That's 5, that's 5. And the sum of how many digits is still to be determined. 2, 3, 4, 5, I don't know. But that's a 1, that's a 3. Here we need 2, 4, and 5. That's not 2. Here we need 3, 6, and 9, so that's 6. And 2 doesn't work here. That would make a sum of 3. Would 9 work here? No, a 9 here would mean that the remaining digits sum to 5, but the 5 here would take the sum of 5 digits, which would be much bigger than 15, and a 4 here would mean the fourth digit is 1, and that doesn't work. So that's a 3, that's a 9. The 1 on this column is here. We still need 4, 5, 7, 8. There's an 8 and a 7 here, but that's 7, 8. And this row needs a 2 and a 3, so they must be like this. And that's a 2. And if I try to put a 5 here, then I need those to be 1, 2, 3, 4, but 4 is not available. So that must be a 4, 8 plus 7. And now this 72 is done. So the rest should be classic Sudoku. First, let's use this 7 to do some disambiguation. And that is classic Sudoku indeed. So that's 9, that's 6. Here we need 5 and 9. Here we need 5 and 6. Oops. So that's a 5, that's an 8, that's a 7, that's an 8, and that's a 7, and a 4. And that's it. Right, so excellent construction by Richard, as usual. And I hope you liked, I always like puzzles with arithmetics. So thanks for watching this video, and see you soon on SudoKanard.